Okay, I think we're good. Right, so topics. The covenant trees. I have made I think that flat versus nested doesn't necessarily work because if I look at how Deno does imports, URLs are effectively arbitrarily deeply nested. NPM finally opened up package scoping, so they surrendered to, flat isn't best there. But these new sort of ES6 imports are allowing you to put paths on things in your package. So you're like scoped name / package name, and then now you're inside package JSON got all these different paths that you can export. Deno is going with the full URL. The web's always been full URL. So I just figured that nested makes it easy for me. And I just wanted to go through the process of the design that I've got and see what you thought, I guess.
Yeah.
I'll just pull up an example file here. Because the thing that makes me a little bit queasy is the way that I've referenced nested schemas within the covenant. So this is the covenant of the CRM. And if you see what I've done on lines 29, 32, and 36, you maybe not that impressed, or you might think it's okay.
Is hash like here?
Hash in JSON schema, hash references the root schema. So you can do any paths you want in the object. In JSON schema, you start with hash and then / blah, 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 and gives you your pathing down. I added a key to the covenant structure called, interestingly enough, covenants. And in there is where you must export your covenants that you want to nest relative to this covenant. Keeping in mind that those exported covenants may also have nested covenants within them too.
Right.
And so, for example, on line 36, where it's like hash / settings, I might be saying hash / settings / database sync, or, if settings also had some nested covenants in there. And the reason why this is easier is because when I'm developing, I need to do an override on the covenant in the chain so that I can hot reload the function, the reducer. If I have to import everything or overload everything, it can be a little bit cumbersome. But, maybe it's not that hard if I exported everything and then just made a single object that had like 100 different keys for all the covenants it wanted and took it from there.
No, I mean, I think the expectation is always that the module reloads without reloading all the other modules, like that you do a topographical reload from this point all the way up to the root.
Right. I kind of expect the tree of covenants to be snapshotable. Like I expect them not to drift. I expect them to be a consistent tree that all works with each other, not not imported at different version levels and all this. I expect them to be holistic.
I don't actually have a problem with this. I would say there is one convention you'd want to follow, which is the root is explicit like this, or if you want to, you can also reference things relative to here, right?
relative, so like dot slash. I think JSON schema allows that.
Right. So like the default way of doing it is saying if I have, so you've got these covenants that you're exporting from this right here, right? Which is saying
Yes.
these ones are all direct children of this one, right?
Yes.
So if they're here, then I should be able to reference them by just like customers without the root, like the hash slash, right?
Yes, I think so. I don't disagree with that. I just haven't wrote the parsing and the test cases to deal with that. But I think that we should actually follow the JSON schema pathing conventions.
Okay.
Because we got to follow something. I think stepping up a level again, the problem I have with covenants is that they're basically the third layer on top of two previous layers.
Mm-hmm.
So we've got like the hash-based IPFS layer, which is just like it's unstructured data. We give it meaning, we give it structure. It's what it brings to the table is hash and distribution, verification, those types of things. On top of that, using public key cryptography, we've put on top of that a layer to provide object modeling by allowing the concept of mutability. So by using signatures, we can assert that a certain value now points to this new hash as opposed to this previous hash, because the layer down below, content addressing, is really just flat. There's no concept of mutation, but we need mutation to be able to have meaningful retrieval systems, right? It's like, what does latest mean? Well, it depends who you ask, right? But anyway, the pulse layer sits on top of the IPFS layer. Then on top of that, we've got the covenant layer that uses, I've tried to use the same pathing mechanisms that are used within the pulse layer.
Yeah.
But now the pathing mechanisms also have this nestedness about them. And then inside those covenants, then you've got the conventional programming trees like package.json or your Rust crates or your Python packages. And it's sort of like, have we put in one layer too many?
Yeah, I get what you're saying.
Like, should it all just purely be into pulse layer pathing?
Yeah.
And there's no concept of nesting covenants. It's just paths, and you can do nesting within the paths.
I mean, that seems the most obvious to me, right? Something I've been trying to like poke you about a few times when we talked is like, if the covenants live with the chain, right?
If the covenants live with the chain,
like if structurally the code, like if the code lives with the exact same like topological structure as the data, then you ought to be able to grab any tree in the data that you want and just punch out the covenant in it and replace it with another one. And like that would be very politically flexible because you could allow things to grow with like a standard covenant set like data and collection. And then as the political rules got more complicated, you would just turf the collection, like turf the collection, replace it with something that has more advanced like
reducer logic,
right?
Right.
And I think they're like the vision I have in my head is like there's just a giant JSON object in the world, and like certain nodes of the JSON object are like more and more complicated over time, right?
Yes. And they begin to sort of unfurl, and then suddenly they're too big, and so there needs to be like a snip, and now that's its own thing. Some other problem turned up.
It's not even a snip. It's just you might draw a bubble around it in a slightly different way, right? Like I would say probably 80%, I would expect, of the code changes are related to governance. Like how would you change this piece of data and not like, not what is the, or how would you change this data based on who you are as a person and what your relationships are with other people, right? Versus like, how do I encode this data differently or whatever, right? Like who cares about most of that stuff, right?
Yeah. I mean,
so
no one does.
to me, the structure that makes the most sense is that the code is very like deeply coupled with the data, like in the actual like data
Okay,
shape.
Yeah, the data shape and the covenant shape needs to be at least relatable in some way. Is that what you're getting at?
I mean, I would think that the covenant would never not be like tightly associated with the subtree that it's like got access to, basically.
Did you say never not be? So
Yeah.
would always be.
Yes.
Yes. Okay.
Sorry. I'm sorry. Like I'm
okay. Well, I can agree with that in terms of my limited building experience with the system. The covenant tree always refers, at least in like it doesn't exactly map to the data tree, but it certainly looks very similar.
Okay, so let's talk about edge cases where it doesn't.
Where I have used system covenants as opposed to application specific, I was able to reuse a generic piece of logic. In that case, the covenant refers to this thing way over here, unrelated. So it's really just there's a tree of covenants that absolutely represents one for one the tree of data, because every data chain has a covenant, and then some of those are replaced with system covenants which come from other places, and what remains is the part that's unique to this application. Over time, sorry?
Can you do a more specific example than that, like a very concrete example?
Yep. So here's a link I've just sent you to how I've been using that nestability. In line 12 of the collections list, that's where I have used the developer override to provide the root covenant of the CRM. If you look at line 7 of that file, I have referred to a nested covenant within the CRM, the /customers nested covenant, and I have installed a chain that only has that because I want to focus exclusively on dealing with the customers. I don't care about the rest of the application. So I've installed the customers covenant in its own dedicated chain. I have begun to populate it with fake customers, and then in the UI I can analyze the effects of that and interact with it under different conditions and really polish the nuts out of the customers covenant coupled with the UI in isolation from everything else. Which has been beautiful. Actually, it's been painful, but like a deep tissue massage.
Okay. So that's the reason you want the customers to be a separate covenant, basically.
Yes, that was the driving force between it. Sorry, I did not lead with that. The driving force was to be able to separate out the individual covenants of the overall application so that they may be processed in isolation. And over time, I would expect a very popular application would have all of its unique covenants genericized and moved out to be away from it. So you were only left with the root covenant, which was a composition of all these generalized covenants. That's what I would expect to happen in a good app.
Yeah, like as the thicker the components get, the more they do the work internally to kind of model everything else in the system, right?
Yeah. And so this nesting notion is really only required until the covenants get fat enough to be referred to individually.
So you haven't really violated this, like the data structure to code kind of relationship here, right?
No, I think when I rang you, and was like, something's drifted and I don't know what, that was the thing that had drifted. The component, the React componentry had drifted from the data structure, had drifted from the covenants. And so after our talk, I managed to bring that strongly back together. And now it is inseparable in a way that it's very difficult to go outside of the structure as defined by that covenant.
Right. I mean, ultimately, like, I know a lot of people say that like code and data should be as decoupled as possible, but I actually kind of disagree. Like,
I disagree too. I mean, the code needs to be aware of its data. I mean, here, the way we're doing this, the code specifies the schema of the data. And without the data schema, like, what are you? You're just like MongoDB or something sloppy like that. Like,
right. And the data needs to be aware of its code too, right? Like, if you're looking at data, it should be immediate to find like the rules of how to change it.
Yes. Yep. So in that case, the reference to the covenant of the data tells you instantly where to go to look up to find the code that modifies it. And you should be able to get a good idea just from the name.
Right. So I'm mostly fine with this. I just think that there might be like a sugar to make it a little bit.
Yeah, a bit of sugar somewhere.
Like, I can also think here, if you're passing in like the root covenant, and then you're also passing in like all of the things that you actually want to keep for this specific like slice of it, I guess, right now that you're working with by name, then it should be smart enough to know that like those covenants would need to be picked up as well. Kind of like how in the IFORM, if you want to pass in all of the subtypes in a list at the same time, like then all of your types just reference subtypes, right?
Right.
And like you could still make like totally assembled objects.
Right. So you're talking about like if I pull in a node from within the tree, it should be definitely aware of all of its children.
Well, so what you're trying to do here right now is not, again, just think of the relationship between covenants and data as like the relationship between class and object, right?
Yes. That's exactly the relationship with one. Yep.
Yeah. So like,
let me just write that down. Okay.
So like if you have just a flat list of classes, like then every object can reference, like can keep track of what class a child in it has, right? Like that's the way the schema language works on.
Yeah, but the benefit of the pathing, the POSIX pathing, is that you can group things together and still have that property.
Mm-hmm.
So having a flat list, whilst it does work, you could think of this a file system as a flat list, but it's just like it's got the folder name in front of it for the key.
Yeah, I mean, I don't think we're actually saying anything that.
Right. I think what's bothering me is that ultimately I would like to get to the point where we can replace package JSON with references to chains. And at that point, when you've got this covenant, you load it up, you get its dependencies from other chains. Now you're in this other lookup system. And why can't the covenant lookup system be the same as a generic package lookup system? Why can't it be the same as the Deno import maps, the same as the Python package list? Like why does it feel like it's another separate way to look up code? And finally, my last sort of itch is the Interpulse engine itself. How is that published? Ought it not be a covenant as well, which should be the same as a package JSON dependency shouldn't all these things be the same reference lookup model?
Right.
Yeah.
Yeah.
And
yeah.
That's my
I see where you're coming from. So what I think is you need to not confuse, like you need to not confuse the instance versus the class, right? Like versus the description of what the instance will do. So covenants can be objects in the system that are that are subject to their own change management, right?
Right. So they have like versions. They have like next, latest. They fork. They have children. They have build artifacts. They have.
Right. But when you're trying to pull in like a covenant to work for you in the covenant that you're building right now in a covenant package system, like you're referencing the factory, not the widget that comes from the factory, right?
Yes. Yep.
Right. So like whatever covenants are, they basically need to, if they live in chains, I believe that the processes that actually spawn from the covenant can be considered children of those chains, right?
One more time, please.
Covenants that spawn, or like instances that spawn from the covenant, like in a certain way, they are children of the covenant at that moment, right?
Or instantiations of that instance of the covenant at that moment.
I'm trying to use the language that we've built up so far here, right? Like if a covenant is a chain, then then what relationship does an instance of a covenant running have to the covenant chain?
Oh, I can answer that. The covenant is a special case where we would like to make data executable. It's simply a reference to some other data with the flag, this is executable. And when you process it in this way, you can execute it. That's really the difference. And if you think about that model for the engine itself, the engine is a reference to some hash-based code that we want to pull in and execute. So I should be able to run old versions of the engine just by having a reference to the engine. So I'm like, here's my covenant reference, here's my engine reference, pull in these data, load it into executable space, process in isolation, give back the results, store it. That's the next piece of data. That they specify together, they specify the transition function for the starting data to the next piece of data.
Right. So like, let me try and back up and come at this from the outside one more time. Like, if you just think of like what we're really trying to do in all of this is we're trying to keep every possible relationship between people and data and like systems explicit, right?
Yes, but I feel like I've ended up. Yes, that's correct. I just feel like I've ended up with a contorted definition because there's like the thing, then there's a pointer out to the engine, then there's a pointer out to the covenant, and then within the covenant there's a pointer out to the package JSON referenced items, the npm packages or whatever, and then that all comes back into the data layer.
And it's just dangling, right? Like some of those.
It's like why are there three types of reference? Why is there not one type of reference?
Right. The way that you're trying to keep relationships wrangled and explicit is by giving them like specific behaviors and names in the chain layer, right?
Yeah. So like the pathing identifies it uniquely.
Yeah. So I think there's a very real way that you can say here that like there's a high amount of utility if you were to actually capture like it was this version of this covenant that ran and created this instance of this chain, right? Like if you said I instantiated this class at this moment in time and it created this chain from
that the pointer would resolve to a specific hash. That hash holds the covenant. So you have the integrity of your executable code is assured by the hash of the covenant that you looked up.
Right.
Like it's not mutable. It is fixed.
Or maybe even another way of saying this is like, have you got an action level description of what it means to execute something?
An action level description of what it means to execute something.
I have a feeling this is the thing that we like keep circling around and never being able to understand. Like, in order for the relationship to be completely captured in Chainland, you would need to have a couple of actions described from the covenant, right? One would be instance, like create a chain based on this covenant, and the other would be execute.
Right. So the way I dealt with that was publish. So you have an action called publish that uses a covenant that I unimaginatively called the covenant that defines all the properties you need to store to define a covenant such that when the engine follows the symbolic link to that particular pulse, it has all the information it needs to load the data reference there into executable space within the CPU and process the data that came in from the chain that held that symbolic link. Is that
yeah? So there's always two, right? There's always
the data that will be executed and the data that will be processed by the execution.
Yeah, I can do that.
It's the whole lambda calculus thing in the programming books. I'm like, sorry, it's slipping from my memory right now. Let me do a little bit of aggressive Googling here. You might I might be barking up the wrong tree here completely. I think the thing is the three different pointers that you have are kind of why aren't they all the same one? What you're trying to say is how do I pull how do you make it very clear how you would start to turn all of the node modules into covenants, right?
Yeah, well, that's sort of already done for us because of the implicit relationship that NPM makes with package.json and the node modules folder. There is no code-based relationship there. It is purely an implicit relationship. NPM makes this folder, it reads the package.json, it pulls the stuff in, and then the implicit relationship is carried forwards into the engine. When the node engine runs, it knows that there's this implied thing that it expects to have node modules based on the package.json, and those relationships are not explicit. They are contextual. They are there because of you sort of just expect them to be around, right? It's the implied way that you run this type of code. But if we want to make that explicit, we need to intercept that. First of all, we need our own version of NPM that reads the package.json and then makes chain-based links instead of the node modules folder.
Yeah.
And then we need an engine that when it goes to load, it has its loader intercepted. And instead of going to disk and node modules, it goes to chain.
Right. So, the thing that strikes me as very different between package.json and or the node modules folder, I guess, and the type of systems you're trying to build here is that the code is very co-located with the chains here, right? You don't have to have this side thing that you bolted on that's just addressed properly in order to know that when I dive into this dependency, it's cleared all of its dependencies. Off somewhere else, right?
Right, and it would also allow it to be lazy loaded. And if it operated in the browser, you wouldn't need to have a bundler step, because if the browser can load based on hashes, then it just loads what it needs at the time for whatever path the user took through the application, and it may be able to reuse the cache from any other instances that we're running because it's hash based. So
now I guess like maybe I'm being a little too aggressive about the symmetry. I think maybe it's
right.
not possible to actually have your code like dependency structure be so closely mirrored to the data that it's managing. Like maybe that's not possible.
All right. Maybe, yeah, okay. Maybe it is not possible because of the way that Node and NPM have structured this implicit dependency. So it needs a translator layer. Like I would feel more comfortable with the tree by calling that type of it a translator layer where we have to accommodate the expectations of an existing engine.
Yeah, I mean, you're never going to
I
get
can
away
live with
from
that.
Like you could go the Go direction, and you could say that every covenant has to bundle all of its dependencies, like in the binary, basically.
Or
No, but like, what's the long-term goal here? Is basically to build a system where, like, those dependencies shrink from the isolation layer and the need to exist in folders beforehand, and they slowly get subsumed by standard covenants, right?
Yeah, that's right. That's what I want. And then, but I guess what I'm asking is, can the reference to the engine be included in the covenant? And should it be? Rather than the reference to the engine being independent of the covenant and specified in the chain. Should the covenant specify an engine version? And what does that mean for the data structure? Because, like an engine has a pulse structure within it, and you should, where is the correct place to put the reference to the engine covenant?
Yeah, you need something like a package.json for every covenant that you're building, right? Like you need
at the moment, at the moment that's the config, and then I'd use the file pathing within the covenant to refer to dependencies. So like the CRM covenant chain has children called customers, settings, routing, all that. Those are dedicated covenant chains themselves.
Right. Okay,
where does the engine reference go?
Like, you're not looking down at that point, you're looking up, right? So it doesn't feel right in the same place.
It doesn't belong. Yeah. And then to complicate matters further, you got the IPLD schema guys saying that because IPLD schemas are so fast, stack them and grab the first one that matches, and that's your implicit versioning. So are we saying we would do the same with engines, where we'd have the latest engine, we'd come down the stack, and then whichever pulse format matched first, that's the version of the engine that we're using.
Oh boy.
How much time have you got, by the way?
Yeah, like 10 more minutes.
10 more minutes. Okay. Can I leave you with that one, because we may not solve it today?
Yeah.
And can I jump on to? I think I've got the problem across. I feel like you see the problem. Some thoughts on it would be great if any pop up. The other topic I wanted to cover was transients in the engines, and the solution I had to that was to allow you to make a new type of engine. Let me just pull up the test format that I've been playing with. I'm not sure if my JSX is going to copy into the chat correctly, so it may look fun as all hell. But basically, when I'm deep within the component tree, I want to be able to create a new transient engine that has full access to read the existing engine, the existing pulses in the file system, but I want it to intercept the execution of anything below its mount point so that it entirely exists in RAM. So for example, the customers list is very large. I do not want it to have to copy that data around. I want it to simply read it from the existing collection of customers. But I want to do a preliminary of what today's trucking routes will look like in a transient form that the user plays with and gets right before committing to.
Okay.
And we're committing broadcasts it to all the other users. This is just for me. So this is like my unsaved files, as it were. And the idea I came up with was this transient engine that just sort of sits there. The primary engine, or the production version, is unaware that anything's happening. It's just sitting at this intercept point. Anytime the code below it tries to read from higher than its mount point, it gets the production version of the chain, and anything lower is its own in-RAM transient version.
Okay. What's the depths part of this here? You're saying like you're going to punch out like subtrees that way?
The dependencies would be when something changed, like when the customer's collection changed, I need to regenerate the transient engine because some of the data that it may have built itself upon has altered. So I need to explicitly say what parts I care about. Like I don't want to reload on every change to the root of the complex. But there are some parts I will care about.
Right. That feels more like a hook than a component.
Okay, well, let me give you another use case then.
Yeah.
I've been thinking about taking this transient engine and writing that chain at the root of the current engine, so that, for example, if you reload the browser page, your unsaved edits are presented back to you. They haven't been lost. And it's just referred to as transient chain 1, held in the transient directory of your root chain. That just gets loaded up. If you open up this component tree again, it will look for the transient chain by name to see if there was anything else previous. If there's something previous, it loads it back up, so you're right back where you started. Sounds like something you want to have happen as a user.
Right. So you don't get backup.
It's like a local copy of your edits.
Right. I mean, I guess what I'm kind of wondering is like, is that behavior that you can provide like in the covenant level? Like,
okay.
Sorry, what, like?
So like not use the transient nature at all, but have.
Like I get the value of it being generic, right? That you can just say like, this is expected to be kind of dirty, slower updating. Doesn't need to live on the production system immediately, right?
Right. But it's not just about speed. It's about you may not want to alter the production system just yet.
Right. But is that application specific behavior, I guess, right? Like
so should it be published to the unsaved files thing that everyone can see in the production app? Like, should it be synchronized with the production tree is what I think you're saying.
No, not quite. okay, everything that happens in the covenant is always like blocked, basically, right? It is always pulsed.
Yeah,
right.
It's always pulsed. Yep.
So there's no way to avoid it going up in front of other people at all.
Well, there is because your local engine does not publicize. It's private. The root of your engine is always private, and then the production app is mounted at a path somewhere, like / prod / trucking. Right. And so you load the React tree at that path.
Right. And the stuff that you do is it's all still being pulsed, but it's being put into your local copy, right?
Yeah, your local copy, which might be shared amongst computers that you have access to.
Right. So that strikes me as something that, like, it almost feels like, what kind of frequency would you want to emit the join requests at, almost, right? Like there's
So I think what you were suggesting was that if I was in the production chain and I had a need of transients, shouldn't I make a folder there that said drafts, and then each user makes their own draft, and it is published in the production app, but it's marked as draft by the application logic?
No, not quite, because there's definitely like there's value to privacy, like dirty working spaces that you don't want to expose to other people, right?
Right.
But
then if you wanted to collaborate with another user, it's useful to have those drafts there.
Right. So there's multiple levels to drafting, right? There's like the drafts I'm not willing to show yet, and there's the drafts that, now I want to start working with other people.
Right. But I mean, I could maintain the privacy just by using permissions on each chain, so that in the production app, the people who have access to your draft are you and the server quorum.
Right.
Right. That's still private-ish.
And more private than that is, like, I have a mirror that only exists with me as the validator on it, right?
Right, but that might be if your machine drops, your draft was lost, and depending on how deep you got into your drafting, you might be mad about that.
Right. Well, so I guess, like, there's the user session level, right? But there's also the my cluster of devices that like back up everything I'm doing as well.
Yeah. And so since, especially at this early stage where the root chain is not shared between all your devices,
right?
I think what you're saying about putting it in the production app actually makes more sense here.
Right.
Because I can avoid having to make the transient engine component out of pure laziness / efficiency. And I can just make another pass in the app. That's actually better, I think.
Yeah. I actually think you can make both. Like
there's value in the transient engine, right? Like yeah. But is that really necessary when might I just be forking prod and then running my own fork?
To me, that's the way I would think of it if I was trying to express it purely in terms of like the language of chains, right? Is like, I want a local copy, which is I'm the only validator on. It's maybe backed up to all my other devices, and then I modify the draft folder locally, and then I make a PR back to prod eventually to make the draft available to everyone.
Right.
And then there's probably some application logic that says, once a draft hits a published state, once it hits a published state, it's now in the actual core data set rather than There's like
that's so
that pattern is going to be very probably everyone will want to build the same pattern, right? And that's the value of the transient engine.
But is it even the transient engine? I think you've convinced me it's really just a fork.
Mm-hmm.
That's not a transient engine at all. That's the transient engine would just be sugar at that point.
Right.
Like it's just componentized sugar to just be like, actually what you're doing is you're forking prod, mounting it in the root, redirecting or pointing all of the React components to point to that fork, and back you come. And in fact, how I want to move once I get more time is that forking prod is the only way that any user interacts with the app. Every version is a fork that they work on, and it's the application logic running in their browser that says when to do the PR back and when to pull merges down.
Yeah.
So there is, if there's only pull requests, then your internet connection is completely independent from your working experience.
Mm-hmm.
Whereas right now, the fact that you need to interact with prod, you need the net. You need to be in touch with Quorum to be able to have an application experience. Let's call it that, right? But if it was by default fork, then you just go for it. And if your net drops, you wouldn't notice.
Right.
The app just carry on.
Yeah. I mean, that, like, to me, that sounds like basically what a session is in this system, right?
That's what it should be. That's not what it is right now.
Right. I mean, it sounds like you don't want to necessarily schedule working apps behind creating a merge system. Like the merge system would be the hard part there, right?
It's actually, whilst the merge system is not implemented, I actually don't think it's that hard to do. I think it just needs an extra system level action that's like at pending merge or check merge, and then the covenant logic can look at the incoming merge and the current state and decide whether it wants to accept it or not. So instead of accepting actions through the covenants API, you would now also need to define state transitions and know how to deal with potential state transitions, which is not as daunting as it may sound, because if everything's defined by a schema, you're like, pass the schema, doesn't pass schema. Okay, logic check from this transition to that. Does the logic pass? Yes or no? Reject.
Right. State transitions maybe boil the problem down to its ultimate essence, but like there are actions and there are state transitions that are non-commutative in time, right? Like that's the hard part of any merge. Things that like have to happen in a certain order or else they have completely weird results.
Like what?
So I mean, a simple example is rotating a cube in 3D space. Like you can't, if you rotate it, if
you stored the coordinates by absolute position, then and you said the latest merge wins.
Right. And yeah, I guess.
I think what you're getting at is that the type of application is heavily dependent on how you will handle those merges. Because, I mean, I would suggest that, for example, if it was document editing, then you'd actually want to be, your underlying data structure should be an operational transform, not document state. So that an incoming merge really takes these transforms and tests the transform incoming. Right, so giving you that covenant hook that says incoming merge, and then you're like, oh, it's got these extra transforms in it. Let me just check if those apply to my logic. Yes, okay, allow merge.
If you make it that way, there's a very, very strong incentive to make all of your data structures into CRDTs.
Or operational transforms.
Or op transforms, So like, if you, I like that. I just wonder if that's like a low tier developer thing to, is it a hard type of data structure for like a bad programmer to understand?
Yeah, it is, because it's not it's not like just the data. But I think that I mean, just going slap with the latest state makes a lot of sense until it doesn't, right? Like most apps could get by with just a rude sort of a force push.
Right? I mean, that's how I use my databases already right now. So you came in first. Too bad for you.
Yeah, right. Sucks to be you. Bye. But I guess the thing that we would lose there is we would lose the actions that were used to compose the transition.
No, you in their state, right? They're going to be there. They're just going to be finalized already.
They're going to be there, but are we saying that when you go to merge, are we going to re-execute the actions that came in, or are we going to say we don't care about the actions, we just care about the state and we just verify the state?
So there's two different ways you can do it, and I think that there's value to preserving both, right? There's like, can I assume that somebody else, like politically, can I assume that somebody that ran this locally and created their own local copy of a block wasn't doing some like fuckery, basically? Or do I want to rerun the actions right from the actual like original action and let the validators do the work, right? Because if you're doing a merge, it's like you're basically saying, I trust the person who validated this, even though they're not part of my validator network.
Can you say that one more time?
You're saying, like, if you're doing a merge, you're saying I trust the results inside this pulse.
Yes.
Right. And that those results were generated by someone that's not this validator network. So it's just it's two different operating modes, right? It's like
right. So you might say that I want full verification where I'm going to rerun all of the actions that came in with the pulse, including its history. I'm going to require that it have been forked from this chain ID initially, and then I'm gonna, if it all passes, then I'm gonna run the state merge checks if the covenant requires it.
Or another way of thinking about it is I'm gonna generate the same pulse as this, and I'm gonna check that they match deep, right?
Right.
Before I merge it. So it's like do I need to do the work to double check it or not? And you can actually, if you build a CRDT as your like data structure, then you actually don't even need to. It's like
no, that's to really put a requirement on your data structure to be chosen correctly. Because we could even offer a mode where we're like grab all the actions and just replay the actions on top. Is that going to give you the result you want? Maybe not. And then what if it's like a three-way, like someone else wants to come in as well?
I mean, I almost kind of think that like the ultimate thing it's trying to say here is like data should always be in the data structure. Data should always be segmented by like the person who's contributing actions to the app, right? They have their little zone that they can affect, and like like if the system can pick up that it's structured that way, it can just say I'm merging instead of I'm checking the merge.
Right. So if the app was designed correctly, you could just do squash merge without checking all the commits in between.
Yep.
Yeah. Okay.
But I feel like we've gone far.
Yeah, I think also, given that if the file system structure was used to make enough granularity in the app, then the places where conflicts could occur would be sort of much easier to deal with. So instead of this huge merge, it's really just a series of small ones that's much easier to comprehend.
Yeah, I mean, the file structure, if the file structure maps cleanly onto the political boundaries in the group that's using the software, then there's almost never going to be conflicts, right? Like if it's very clear who should own what file.
Yeah. Well, I mean, if two users are updating the same customer record, that kind of needs to come down to a timing thing, like who got there first, and should we tell each of them that there was this degradation out from under them, there was this conflict that they may or may not care about. Like basically the UI needs to be built in a way that it supports surfacing conflicts and resolution of conflicts, so that your customer record should show up as like orange, where it's like, when you edited this, it was this, but then when it got merged, it was being merged from this. And do you care? Please just take a look.
Yeah. So I mean, every UI piece can be in like a multi-parent unmerged kind of mode, right?
Yeah. And I think that each app actually needs an event log. Like you should give the user an event log where you can see the almost like Git branches, where you can see that where conflicts occurred. So you can trace down how everything happened if you want, but it will also highlight to you areas that you may want to double check. It's like, these merges came in, and relative to what you were seeing, these were the differences. So you can choose to just check them over.
Right.
I think that's the way it has to go, but there are some definite quirks in how you make your app.
Right. I actually like it. I like the idea of sending a computed pulse in that has to be, if it's in an untrusted system, validators of the foreign network would try to recompute it, and they can give a trust score to me basically based on how often they see that I'm sending stuff that doesn't work.
Right.
That moment actually feels like a good one to try and preserve something.
Okay. All right. Well, I think for the sake of expediency, I'll go with making the drafts part of the application structure, because that's super easy. Hadn't even thought of that, but it's super easy. And then long term, make this transition to forking and merging as the only way that application updates are pushed into prod. So right now, your user chain makes a connection to prod and edits directly, but that means that you have to wait for prod to accept your changes before you can really move on.
Right.
Whereas if it's all fork and merge, you just go for gold whenever you get around to it. You'll catch up.
Yeah, makes sense.
Okay.
Cool. I got to jump off.
Okay, sweet. All right. Thank you for your time. I'll let you know how I get on, and I'll hopefully send you a storybook with a fully working blockchain CRM this week.
Hopefully. That sounds fun. Cool.
Yeah. Okay.
Right,
Thank you. See you later.